Every star has a life, a story written in fusion and gravity. And just like living things, stars are born, they grow, they age, and they die, though on time scales measured in millions or billions of years. Their life cycles create some of the most spectacular and exotic objects in the universe. Stars begin in nebulae as vast clouds of gas and dust. Under gravity, clumps collapse, heating until nuclear fusion ignites. A newborn star glows, fusing hydrogen into helium, balancing the inward pull of gravity with the outward pressure of radiation. For most of its life, a star is steady, shining quietly in this equilibrium. But the mass of a star determines its fate. Small stars like red dwarfs burn slowly and steadily for trillions of years, far longer than the current age of the universe. They fade into white dwarfs, cooling embers that slowly dim into black dwarfs, though none yet exist because the universe is not old enough. Medium stars like our sun swell into red giants when hydrogen runs out. Their outer layers expand, engulfing nearby planets, while the core contracts and fuses helium. Eventually, they shed their outer layers into glowing planetary nebulae, leaving behind a white dwarf, a dense Earth-sized remnant packed with the mass of a star. Massive stars, however, meet a far more violent end. When fusion can no longer sustain them, their cores collapse in spectacular supernovae, explosions so bright they can outshine entire galaxies for weeks. These explosions forge heavy elements, iron, gold, uranium, and scatter them across space. Every atom of calcium in your bones, every bit of iron in your blood, was created in such an explosion. We are, quite literally, made of star stuff. After the explosion, the core may collapse into a neutron star, an object so dense that a teaspoon would weigh billions of tons. Some neutron stars spin rapidly, emitting beams of radiation like lighthouses. These are pulsars, ticking with astonishing regularity. Others become magnetars, with magnetic fields strong enough to tear atoms apart. For the most massive stars, collapse continues past even neutron density, creating a black hole. Here, gravity is so strong that not even light can escape. At its heart lies a singularity where our current understanding of physics breaks down. Surrounding it is the event horizon, the ultimate one-way door. Black holes are both destroyers and creators, tearing apart stars, but also driving galaxy formation through their immense energy. On cosmic timescales, even these remnants evolve. White dwarfs will cool into invisible black dwarfs. Neutron stars may one day evaporate or decay. Black holes, through Hawking radiation, will slowly lose mass and vanish, leaving behind faint whispers of energy. Over unimaginable epochs, matter itself may decay, protons dissolving, leaving only radiation in a universe grown dark and cold. This far future scenario is called the heat death of the universe. If expansion continues forever, stars will burn out, galaxies will disperse, and black holes will fade. The cosmos will become a thin soup of particles and energy, spread too thin to form new structures. Time itself may lose meaning in this eternal darkness, and yet the story may not end there. Some theories suggest cycles, universes born and reborn, eternally expanding and collapsing. Others imagine the multiverse, where new realities bubble into existence endlessly. The fate of everything may not be death, but transformation, renewal, or infinite variation. Stars live, die, and leave behind the building blocks of planets, life, and thought. Even as the universe trends toward entropy, the pattern of creation and transformation continues. The cosmos teaches us that endings are beginnings, and that even death creates new life on grand scales. When we gaze at the night sky, we confront a paradox. On one hand, humanity seems infinitely small. Earth is a tiny world circling a medium-sized star, one of hundreds of billions in the Milky Way itself, one of trillions of galaxies. On the cosmic scale, we are less than a grain of sand on an endless shore. And yet, on the other hand, we are significant because we know. Out of countless stars and planets, we're aware, asking questions, measuring starlight, building telescopes to look back to the dawn of time itself. The universe may be vast, but as far as we know, it cannot contemplate itself, except through us. The idea that we are made of stardust is not just poetic, it is literal. Every element in our bodies heavier than helium was forged in stellar furnaces and spread by supernova. Iron in our blood, calcium in our bones, oxygen we breathe, all were born in the depths of stars. We are the universe, looking back on itself, thinking, dreaming, and wondering. Our myths and stories have always placed us in the sky. Ancient people mapped gods, animals, and heroes into constellations. They told stories of creation and destruction written in the stars. Today, our stories are written in equations and data, but the impulse is the same: to make meaning from the night sky, to find our place in something larger. And in practical ways, space has already changed us. Satellites connect the globe, probe the weather, and navigate our journeys. Probes have touched every planet in the solar system. Telescopes orbit Earth, peering into galaxies billions of light years away. Astronauts have lived in orbit for months, experiencing the overview effect, a sudden realization of Earth's fragility when seen from space. The next step may be even greater: becoming a multi-planetary species. Colonies on the Moon, Mars, or beyond would not just be survival strategies, they would be expansions of human culture, language, and imagination. Each new settlement would carry Earth's history, but would also create new ways of living, shaped by alien skies and alien challenges. Humanity might fracture into many forms: Martians, Lunarians, voyagers of interstellar ships. Our destiny may not be unity, but diversity across the cosmos. Some thinkers suggest that intelligence itself could be the universe's way of resisting entropy. Life, thought, and technology are pockets of order in a cosmos tending toward disorder. If so, humanity's role may be profound: to preserve complexity, to spread life, to ensure that awareness does not vanish into cosmic silence. Others take a humbler view. Perhaps we are a fleeting phenomenon, a brief flare of consciousness before the universe continues on, indifferent. And yet, even if that were true, it does not diminish the wonder of existing here and now, able to see the stars and ask what they mean. In either case, space exploration is more than science. It is philosophy in action. Every probe we launch, every telescope we build, every astronaut we send is an answer to the question: who are we and what is our place in the universe? Whether humanity lasts another 1,000 years or 1,000,000, whether we remain bound to Earth or scatter across galaxies, our role is the same: to be curious, to explore, to imagine. In a universe vast and silent, our voices, however small, add something unique. Perhaps our greatest gift to the cosmos is not technology or colonization, but wonder itself. For all the progress humanity has made, most of the universe remains a mystery. We live in a cosmos where the majority of its contents are invisible, and its earliest moments are cloaked in uncertainty. Each mystery is a door waiting to be opened, and beyond it may lie revelations that transform everything we think we know. One of the greatest puzzles is dark matter. Astronomers first noticed galaxies were spinning too fast. Their stars moved as if pulled by hidden mass. Without it, galaxies should tear themselves apart. Something invisible exerts gravity, outweighing ordinary matter by 5 to 1. We can't see it, touch it, or detect it directly, yet it binds galaxies, shapes cosmic structure, and holds the universe together. What is it? Candidates range from undiscovered particles to exotic objects, but no definitive answer has emerged. Stranger still is dark energy, the force driving the accelerated expansion of the universe. Discovered in 1998, it appears to make up nearly 70% of the cosmos. Unlike gravity, which pulls, dark energy pushes, stretching space itself faster and faster. If it continues, galaxies will drift apart until each is isolated in darkness. Yet no one knows what dark energy is, a property of the vacuum, a new field of physics, something we cannot yet imagine. Another mystery lies at the very beginning, the inflationary epoch. In the first fraction of a second after the Big Bang, the universe seems to have expanded faster than light, smoothing out irregularities. Without inflation, the universe would be clumpy and uneven. But what caused it? Did a quantum field briefly dominate, then vanish? Was inflation the seed of a multiverse, spawning countless other universes with different laws of physics? Speaking of universes, the multiverse hypothesis is both thrilling and unsettling. If true, our universe may be just one bubble among infinite others, each with different constants, dimensions, or even entirely different physical realities. Perhaps life emerges in some, while others remain barren. If universes are infinite, then so are possibilities, versions of reality stranger than any fiction. Closer to home, there is the question of life itself. How did non-living matter assemble into self-replicating molecules and eventually into conscious beings? Did life arise here uniquely, or is it common throughout the galaxy? We've found thousands of exoplanets, many inhabitable zones. Some may host oceans, atmospheres, or even alien ecosystems. And if life is out there, intelligent or not, how would we recognize it? Would it resemble us or be utterly unrecognizable? Then there are mysteries hidden in plain sight. Why do fast radio bursts, powerful flashes of energy, erupt randomly across the sky? What causes ultra-high energy cosmic rays, particles hitting Earth with more power than human-made accelerators? Why do some galaxies harbor supermassive black holes so early in cosmic history when there seemingly wasn't enough time for them to form? Each unanswered question is not a dead end, but an invitation. Every mystery pushes science forward, leading to new tools, new theories, and new perspectives. In this way, ignorance is not a weakness, but a fuel for discovery. Perhaps the most profound mystery of all is, why is there something rather than nothing? Why does the universe exist at all? Science can describe how the cosmos evolves, but the ultimate why remains beyond our grasp, at least for now. The mysteries remind us that the universe is not finished with us. There are still wonders hidden in the dark, waiting to be revealed. The story of space is not only about what has happened, but also about what will happen. Humanity is at the edge of a new era, with technologies in development that could open the cosmos in ways once thought impossible. Our next big leap begins with telescopes. the James Webb Space Telescope has already transformed astronomy, peering into the atmospheres of exoplanets and capturing light from the earliest galaxies. But even more powerful instruments are coming. The extremely large telescope in Chile, with a mirror 39 meters wide, will reveal details of distant worlds. The Nancy Grace Roman Telescope will scan wide swaths of the sky for dark energy clues, and proposed missions like the LUVOIR and HABEX concepts could one day directly image Earth-like planets and perhaps even detect signs of life. Closer to home, space agencies and private companies are pushing toward human exploration of Mars. NASA's Artemis program aims to return humans to the moon, this time to stay, with lunar bases acting as stepping stones for deeper missions. Mars remains the ultimate prize, a planet with valleys, polar ice, and a past that may have once supported life. Though the challenges are enormous, radiation, isolation, food production, human footprints on Martian soil may be within the century, but our ambitions don't stop there. Interstellar probes are being imagined, capable of reaching the nearest stars. Projects like Breakthrough Starshot envision tiny spacecraft propelled by giant laser sails, racing at a fraction of the speed of light to Alpha Centauri in just a few decades. Though still in early stages, such concepts hint at a future where humanity might send emissaries beyond the solar system, carrying sensors, cameras, and perhaps, eventually, people. Meanwhile, asteroid mining and space industry could transform economies. Asteroids are rich in metals like platinum, nickel, and iron. Some contain more wealth than all Earth's reserves combined. Mining them could fuel construction in orbit, creating massive solar power stations or habitats like those imagined by physicist Gerard O'Neill. Rotating colonies with artificial gravity, green landscapes, and entire communities floating among the stars. Then there are dreams of terraforming. Mars, with enough time and technology, might be warmed by greenhouse gases, thickening its atmosphere and melting its ice to create rivers and seas. Venus, though far more hostile, could one day be cooled and reshaped. These ideas remain theoretical, but they remind us of humanity's ambition to not just visit other worlds, but transform them. Even wilder are visions of interstellar civilizations. If technology keeps advancing, one day we might harness the energy of entire stars, building megastructures like Dyson spheres, vast arrays of satellites capturing every photon of a star's light. Civilizations capable of such feats would shine in the dark of space, detectable across galaxies. Perhaps they already exist. Perhaps one day we will join them. Yet with every step outward comes responsibility. Will humanity bring life to barren worlds or destruction to fragile ecosystems we don't yet understand? The future of exploration is not just about technology, but ethics, philosophy, and wisdom. To explore space is to decide what kind of species we want to become. Still, one thing is clear. Our story is only beginning. The universe stretches before us, filled with challenges and wonders. Humanity, fragile yet curious, may one day leave Earth not as wanderers, but as citizens of the stars. If the universe is as vast as we believe, filled with billions of galaxies, each with billions of stars and countless planets, then a haunting question arises. Are we alone? The search for extraterrestrial life takes many forms. Scientists scour exoplanets for biosignatures, chemical fingerprints in atmospheres that could hint at biology. They look for oxygen, methane, or unusual chemical balances that might be signs of living processes. Even now, telescopes are beginning to detect the faint gases surrounding distant worlds. Someday soon, we may spot the unmistakable breath of alien life drifting in a foreign sky. Closer to Earth, the icy moons of our solar system beckon. Europa, orbiting Jupiter, and Enceladus, orbiting Saturn, both hide subsurface oceans beneath their frozen crusts. Plumes of water erupt from Enceladus, carrying hints of complex chemistry. These moons may harbor warm seas, shielded from radiation, where life could thrive. Future missions will probe these worlds directly, sampling their plumes and searching for microbial fingerprints. Then there's Titan, Saturn's largest moon, with methane lakes and a thick orange atmosphere. Life there, if it exists, may not be based on water at all, but on exotic chemistry unimaginable on Earth. Finding even a single alien microbe would revolutionize science, showing that life is not unique, but a natural outcome of cosmic processes. But what about intelligent life? For decades, the search for extraterrestrial intelligence, SETI, has scanned the skies for signals. So far, silence. Some argue this supports the Fermi paradox. If intelligent civilizations are common, where are they? Why don't we see evidence? No signals, no megastructures, no ships. Possible answers range from sobering to thrilling. Perhaps intelligent life is rare, and we are an exception. Perhaps civilizations self-destruct before mastering the stars. Or perhaps advanced species communicate in ways we don't understand, or choose to remain silent, watching us as we once watched wild forests. If we ever do make contact, the consequences would be profound. Discovering microbes on Mars or Europa would reshape biology and philosophy, proving life emerges easily wherever conditions allow. Receiving a signal from an intelligent species, however, would change civilization itself. We would know we are not alone. That thought and culture exist elsewhere, perhaps older and wiser than ours. What if the encounter were closer? A visiting probe, an artifact found in our solar system, or a transmission aimed directly at Earth? How would humanity react? Fear, wonder, unity, division. The arrival of proof would be both exhilarating and destabilizing. Religions, governments, and cultures would all need to adapt. And yet, even without proof, the question of extraterrestrial life continues to shape our imagination. It drives movies, stories, and art. It inspires scientists and explorers. It reminds us that the universe may be filled with other minds, other lives, other dreams. Whether or not we ever meet them, the possibility expands our sense of what is possible. In the silence of the night sky, we listen and wonder if, somewhere out there, someone is listening too. Long before telescopes, before rockets, before mathematics could measure orbits, humanity looked up at the sky and found stories. The stars became a canvas for imagination, a mirror for fears and hopes. Every culture across time and geography has woven myths into the constellations. The ancient Greeks saw gods and heroes in the heavens: Orion the hunter, pursued by a scorpion; Andromeda chained to the rocks; Perseus brandishing Medusa's head. These constellations were not just tales, but calendars and navigation tools. The rising of Sirius marked the flooding of the Nile. The Pleiades guided sailors across oceans. In China, astronomers mapped the heavens into palaces and officials, reflecting the structure of their empire. The Milky Way was the Silver River, a celestial divide where the weaver girl and cowherd, two star-crossed lovers, could meet only once a year when magpies formed a bridge across the sky. In Australia, Aboriginal peoples read the dark spaces between stars, seeing the emu in the sky, formed not of bright points, but of shadows in the Milky Way's dust lanes. Its rising marked the season for gathering emu eggs, a blend of myth and practical knowledge passed down for tens of thousands of years. For the Maya and Aztecs, the sky was a stage for cosmic cycles. Venus, the morning star, was linked to gods of war and renewal. Eclipses were moments of peril, requiring ritual to ensure the sun's return. Entire cities were aligned with solstices and equinoxes, monuments built as stone calendars to track the heavens. Even in the modern world, the sky remains cultural. Astrology, though not scientific, still influences millions, showing how deeply the stars hold symbolic power. Literature and art constantly draw from cosmic imagery. Dante placed heaven and hell in the structure of the universe. Van Gogh painted swirling stars in the starry night. Contemporary films project our longing for contact, our fear of loneliness, onto the night sky. Religions, too, have been shaped by space. Many creation myths begin with darkness and the first light in the heavens. In some traditions, the stars are souls, ancestors watching from above. In others, they are the lamps of gods. Even today, when science explains nuclear fusion, the emotional pull remains. A sunset, a meteor shower, a full moon, these still evoke awe that transcends explanation. Space has also reshaped culture through technology. The Apollo missions were not just engineering triumphs, but cultural moments. Images of Earth from the moon, the blue marble and Earthrise, shifted global consciousness, sparking environmental movements and reminding us of our fragility. The night sky has always been a mirror, but for the first time, we saw ourselves from outside, suspended in the black sea of space. Today, art and science meet again in projects like Carl Sagan's Voyager Golden Records. Phonographs launched into interstellar space, carrying sounds, music, and greetings in dozens of languages. These records are not just data. They are messages of culture, saying to the cosmos, this is who we are. The human relationship with space is as much emotional as it is rational. We do not only measure the heavens, we dream in them. Each myth, each poem, each painting of stars is a reminder that space is not just out there, it lives inside us, woven into our cultures, our identities, our sense of being. In a way, we have always been cosmic storytellers, turning cold points of light into warm tales of meaning. And even now, with galaxies revealed and black holes measured, we continue to tell stories. Only now they are scientific, philosophical, and futuristic. If myths were humanity's first space stories, then science fiction is our modern mythology. Long before rockets left Earth, writers and dreamers imagined voyages to the stars, alien civilizations, and futures shaped by the cosmos. These stories, though fictional, have often guided real exploration, sometimes even predicting it. In the 17th century, Johannes Kepler wrote Somnium, a tale of a voyage to the moon. In the 19th century, Jules Verne envisioned a lunar journey launched by a giant cannon, while H.G. Wells wrote of Martians invading Earth in The War of the Worlds. These early works reflected both fascination and fear, space as possibility, space as threat. By the mid-20th century, as rockets rose and satellites orbited, science fiction exploded. Writers like Arthur C. Clarke, Isaac Asimov, and Ursula K. Le Guin crafted visions not just of technology, but of societies shaped by space. Clarke imagined communication satellites before they became real. Asimov's Foundation series considered the rise and fall of galactic civilizations. Le Guin explored how alien worlds might reshape ideas of gender, culture, and politics. Cinema added new dimensions. 2001, A Space Odyssey presented space travel as both majestic and terrifying, blending technology with mystery. Star Trek offered a hopeful vision of exploration and cooperation, where humanity overcame its divisions to journey among the stars. Star Wars, in contrast, framed space as a stage for mythic battles of good and evil. Each story was less about rockets than about ourselves, our dreams, fears, and struggles projected onto the cosmos. Some visions are utopian. They imagine humanity spreading across planets, building peaceful interstellar communities, harnessing the energy of suns, transcending limits of biology and culture. In these stories, space is freedom, a vast canvas for progress, diversity, and creativity. Others are dystopian, warning of dangers. Stories of resource wars on Mars, corporate empires mining asteroids, or authoritarian control of space colonies reflect anxieties about carrying Earth's problems outward. Some tales envision apocalyptic scenarios, space as an escape for the wealthy while Earth decays, or as a cold void where humanity discovers its fragility and isolation. Even within pessimism, there is often wonder. Space fiction rarely rejects exploration outright. Rather, it reminds us that who we become in space is as important as getting there. Will we repeat old mistakes? Greed, violence, exploitation? Or will we learn new ways of living? Beyond entertainment, these stories inspire real people. Engineers at NASA have admitted they were motivated by Star Trek. Elon Musk often cites science fiction as inspiration for Mars colonization. Concepts like space elevators, warp drives, or artificial habitats began as speculative fiction and later became topics of serious engineering papers. Science fiction also stretches our imagination of life itself. What if aliens are made of plasma? What if consciousness can exist in networks or stars? What if black holes are gateways or universes are alive? These ideas expand the limits of possibility, preparing us for realities stranger than our current science allows. Space has always been a mirror for human hopes and fears. Science fiction simply gives that mirror sharper detail, richer color. And whether utopian or dystopian, optimistic or grim, every story reflects the same truth. The stars are not just distant. They are destinations in the human mind. The stories we tell about space today may become the blueprints of tomorrow's missions. In a sense, imagination is the first step of exploration. Space is not merely a backdrop for exploration. It is an environment that reshapes life itself. Beyond Earth, the familiar forces that govern our existence change, and the human body and mind must adapt to conditions that evolution never prepared us for. The most obvious challenge is microgravity. In orbit, astronauts experience weightlessness, floating freely as if they were in a dream. Everyday movements require entirely new coordination. Pushing off a wall can send you tumbling, while holding tools demands careful technique. Muscles atrophy, bones lose density, and the heart reshapes itself because it no longer has to fight gravity to circulate blood. Astronauts exercise hours each day to slow these effects. Yet even with rigorous routines, prolonged time in space leaves permanent marks. Then there's radiation. Outside Earth's protective magnetic field, cosmic rays and solar particles bombard everything in orbit. Over time, exposure increases the risk of cancer and can damage DNA. Shielding technology helps, but it is never perfect. Long-duration missions to Mars or beyond will require new materials, clever spacecraft design, and perhaps even medical interventions we cannot yet imagine. Psychologically, space is equally demanding. Isolation and confinement test the mind. Astronauts spend months in small habitats, often with only a handful of companions. Communication delays stretch hours or minutes for distant missions, leaving individuals to cope with problems independently. Sleep cycles can be disrupted by 16 sunrises and sunsets every 24 hours in low Earth orbit. The mind may hallucinate or misinterpret sensory information when deprived of familiar cues from gravity, sound, and day-night rhythms. Yet humans are astonishingly adaptable. Astronauts report the overview effect, a profound cognitive shift that occurs when seeing Earth from orbit. The planet, a fragile sphere of life floating in a vast void, inspires awe, humility, and a sense of global interconnectedness. This perspective can reshape values, priorities, and even creativity. The smallness of our world against the vast cosmos fosters reflection. Life, culture, and survival appear both precious and fragile. Space also transforms perception of time and routine. Days are measured not by sunrise, but by mission clocks and schedules. Eating, sleeping, working, and exercising become deliberate, highly structured acts. Even breathing is carefully managed, as spacecraft rely on precise life support systems to provide oxygen, remove carbon dioxide, and maintain pressure. Every activity reminds inhabitants of their reliance on technology and the delicacy of life beyond Earth. Future long-term settlements will amplify these challenges. Martian colonies will require protection against dust storms, radiation, and low gravity. Lunar habitats must shield against extreme temperature swings and micrometeorites. Psychological resilience will be as critical as engineering skill, and cultural adaptation may be necessary. New rituals, customs, and social structures may emerge to maintain cohesion in isolated environments. And yet, for all the difficulty, there is beauty. Stars shine brighter without atmospheric interference. Sunsets on Mars cast a blue glow across red dust. Silence dominates space, interrupted only by the hum of machinery, a stark contrast to Earth's ceaseless noise. Living in space forces humans to confront fragility and mortality, yet also to embrace curiosity, adaptability, and wonder. Space challenges every sense, every habit, every expectation. It strips life to essentials, revealing both vulnerability and resilience. Those who endure it emerge transformed, carrying back a new understanding of life, gravity, and the vast cosmos beyond our home. The dream of leaving the solar system entirely has captivated humanity for generations. Interstellar travel is the ultimate challenge. Distances measured in light years, journeys that span lifetimes, and engineering feats that push physics to its limits. Yet for visionary scientists and dreamers, the stars are a destination, and nothing, not distance, not danger, not time itself, can fully deter ambition. One concept is the generational ship. These massive vessels would carry thousands of humans, animals, and ecosystems in self-contained habitats. The journey could take centuries, with multiple generations living and dying aboard the ship before reaching a distant star. Such a voyage would require artificial gravity, closed-loop life support, and social systems capable of maintaining order, knowledge, and culture over lifetimes. Humanity aboard these ships would become a microcosm of Earth, traveling through the void as a miniature civilization. Another vision relies on high-speed propulsion. Concepts like fusion drives or antimatter engines promise fractions of light speed, reducing interstellar travel from millennia to decades. Even at 10 to 20% of light speed, a journey to Alpha Centauri could be achievable within a human lifetime. Challenges abound. Immense energy requirements, shielding against interstellar dust, traveling at relativistic speeds, and the isolation of crew and passengers. Yet these are not insurmountable. They are engineering puzzles waiting for solution. Some theoretical proposals flirt with even stranger possibilities. Warp drives inspired by Einstein's equations suggest space itself could be contracted ahead of a ship and expanded behind it, allowing faster-than-light travel without violating relativity locally. While purely speculative now, research into exotic matter and negative energy continues, keeping the door open for science to meet science fiction. Wormholes, if stable, could also provide shortcuts across the galaxy, potentially connecting distant points instantaneously. Colonization of nearby star systems is another frontier. Proxima Centauri b, a planet in the habitable zone of our nearest stellar neighbor, could one day be the first destination of human or robotic settlers. Sending autonomous probes first, tiny spacecraft capable of self-repair, observation, and communication, would lay the groundwork for future human habitation. Over centuries, entire networks of colonies could arise, forming the first interstellar civilization. Beyond settlement, advanced concepts envision terraforming and engineered biospheres on distant planets. Humans might carry genetic libraries, biomes, and ecosystems to recreate habitable environments elsewhere. In a sense, humanity would become gardeners of the cosmos, seeding life across multiple worlds and ensuring its survival beyond Earth. Even cultural and social structures would evolve. Multi-generational crews may develop new languages, religions, and traditions adapted to life in confined artificial worlds. Our descendants might consider Earth a distant myth, a cradle left behind in a fading solar neighborhood. Identity, memory, and history would intertwine with interstellar travel, making exploration not just a technical feat, but a transformation of what it means to be human. Ultimately, these possibilities, generation ships, fusion drives, warp drives, terraforming, represent humanity's reach toward infinity. The stars are not just destinations, they are tests of imagination, endurance, and ambition. Every challenge solved, every mile traveled, reshapes both the universe and ourselves, ensuring that our journey through the cosmos is as much an inward journey of discovery as it is an outward adventure. If humanity ever becomes an interstellar species, the cosmos transforms from a distant backdrop into a stage for our existence. But with this expansion comes profound questions. What does it mean to live across light years? How do we measure legacy, identity, and meaning when the scale of life itself stretches beyond comprehension? One question is immortality of culture. Individual human lifespans are brief, but civilizations may endure. Knowledge, art, and stories could traverse generations aboard ships, colonies, and digital archives. Each new world we reach becomes a vessel for memory and culture, ensuring that the essence of humanity persists long after our species may vanish from Earth. In this way, legacy is not just personal, it is cosmic. Then there is identity and evolution. Humans living in low gravity or enclosed habitats for generations may evolve biologically, cognitively, or socially. New subspecies could emerge, Martians, asteroid-borne communities, or inhabitants of artificial habitats. Culture, language, and thought may diverge, creating branches of humanity that are simultaneously familiar and alien to each other. The universe may become a mirror of our diversity, reflecting the adaptability of life itself. Ethics also become more complex. Colonizing other worlds raises questions about interfering with alien ecosystems, preserving planetary environments, and ensuring fairness in resource allocation. Decisions once made on Earth could have consequences that ripple across centuries and light years. Humanity may become a moral agent on a cosmic scale, responsible for life, knowledge, and even the fate of worlds we touch. Existentially, spreading across the stars challenges our perception of mortality. Time itself becomes malleable. Multi-generational ships, relativistic travel, and long-term habitation mean that life is measured differently. Some may experience centuries of subjective time, while billions of years pass elsewhere in the universe. In this context, human existence stretches beyond biology, intertwining with physics and cosmology. There is also the question of purpose. Are we explorers by necessity, driven by curiosity and survival, or by destiny, carrying consciousness itself into the void? Some argue that life's role is to preserve order, complexity, and awareness in a universe tending toward entropy. In this view, humanity's expansion is not just survival, but participation in a cosmic narrative, a story of intelligence illuminating the darkness. Yet, spreading through the stars also invites humility. The universe is vast, violent, and indifferent. Black holes, supernovae, and gamma-ray bursts remind us that existence is fragile. Civilizations may rise and fall unseen. Even if we spread across galaxies, we may remain insignificant in the grand scale. Yet that insignificance does not diminish the value of curiosity, creation, and connection. Ultimately, the act of reaching for the stars is both practical and philosophical. It preserves life, knowledge, and culture. It transforms humanity, forcing us to rethink identity, ethics, and meaning. And it confronts us with the sublime, a cosmos that is vast, ancient, and indifferent, yet capable of inspiring wonder, reflection, and purpose. In spreading into space, we are not only discovering new worlds, we are discovering ourselves. As we peer deeper into the universe, both observationally and mathematically, the cosmos reveals possibilities that challenge comprehension. Some of these ideas are speculative, but they are grounded in physics and mathematics, suggesting that reality may be far stranger than our senses allow. Consider white holes, the theoretical opposites of black holes. While a black hole swallows everything, a white hole expels matter and energy, allowing nothing to enter. If they exist, white holes might be gateways to new regions of space or even other universes, spewing matter into cosmic nurseries. They remain hypothetical, but equations suggest they are mathematically plausible, offering a glimpse into physics at its extremes. Exotic matter is another enigma. This hypothetical form of matter would have negative energy density, enabling phenomena like stable wormholes or warp drives. It does not exist in our observable environment, yet its theoretical properties show that the laws of physics allow possibilities far beyond ordinary intuition. Harnessing such matter could, in principle, make interstellar travel practical, or create effects that seem like magic. The multiverse hypothesis continues to fascinate. Cosmic inflation may have spawned countless universes, each with different physical constants, dimensions, or even laws. Some universes may be barren, others teeming with unimaginable forms of life. If true, reality is not a single, uniform cosmos, but an infinite ensemble of possibilities, a boundless playground for matter, energy, and consciousness. On the largest scales, the far future of the universe stretches beyond human imagination. If dark energy dominates indefinitely, galaxies will drift apart until each is isolated in darkness, a process sometimes called the cosmic event horizon. Stars will burn out, black holes will evaporate, and matter may decay. Entropy will approach maximum, leading to the so-called heat death, a universe thin, cold, and silent. Life as we know it may vanish, leaving only radiation and quantum fluctuations. Yet some theories suggest cycles. The Big Bounce concept envisions the universe collapsing and rebounding in endless cycles, each beginning with a new Big Bang. Or perhaps black holes seed new universes, creating a cosmic lineage where our own universe was born from the death of another. In these scenarios, endings are beginnings, and the cosmos is a vast, self-renewing experiment. Quantum mechanics adds further strangeness. Quantum entanglement and superposition suggest that distant events can be correlated in ways that defy classical causality. The vacuum itself teems with fleeting energy, and some theorists propose that consciousness, computation, or information may play roles in shaping reality in ways we do not yet understand. The universe may be stranger than a stage. It may be a network, a code, or a living system in ways we are only beginning to glimpse, even without proof. These ideas expand human thought. They remind us that the cosmos is not a static backdrop, but an evolving, dynamic, and sometimes unfathomable system. Every theory, every model, every speculative idea is a bridge between our finite minds and the infinite possibilities of existence. The universe stretches toward extremes: birth and death, creation and collapse, visibility and invisibility, humanity, tiny and fleeting, watches, measures, and imagines. And in imagining, we participate in the grandest story of all, the story of a cosmos so vast, strange, and beautiful that wonder is the only natural response. The universe is full of objects and events that defy expectation, reminding us that reality often exceeds imagination. Some are violent, some are bizarre, and some seem almost supernatural. Yet all are rooted in the laws of physics, however extreme. One such mystery is fast radio bursts, FRBS. These are intense flashes of radio waves lasting mere milliseconds, yet releasing more energy than the sun emits in days. First discovered in 2007, their origins remain largely unknown. Some may come from magnetars, neutron stars with incredibly strong magnetic fields, but others are harder to explain. A small fraction of FRBS repeat unpredictably, suggesting a mechanism that defies current astrophysical understanding. Rogue black holes are another enigma. Unlike black holes anchored in galaxies, these wander through space alone, ejected by gravitational interactions. Some may drift between stars at thousands of kilometers per second, invisible to most detection methods. Their gravity can distort the orbits of nearby objects, bend light, or if passing through a planetary system, unleash chaos. In the emptiness of space, these lone titans are silent hunters, unseen yet immensely powerful. Then there are hypervelocity stars ejected from galaxies at millions of kilometers per hour. A single encounter with a supermassive black hole can accelerate a star to escape velocity, sending it careening into intergalactic space. These stellar speed demons are reminders of the violent forces shaping galaxies and the delicate balance that allows planetary systems to survive. Some stars themselves behave strangely. Tabby's star, KIC 8462852, dims irregularly and unpredictably, leading to wild speculation ranging from dust clouds to hypothetical alien megastructures. Its behavior does not fit typical models of stellar variability, making it a cautionary tale. Even seemingly ordinary stars can harbor secrets. The universe also hosts exotic planets. Some orbit so close to their suns that a year lasts mere hours. Others are rogue planets drifting through space without a star. Certain gas giants have supersonic winds and rain made of molten glass or metallic hydrogen. Worlds of extreme temperature, pressure, and chemistry stretch our understanding of planetary physics. Gamma-ray bursts are among the most violent phenomena observed. A single burst can release more energy in seconds than the sun will produce over its entire lifetime. They are caused by supernovae, or merging neutron stars, and if one were to occur nearby, it could threaten life on Earth. Yet across the vast distances of space, they are rare reminders of cosmic power. On the edges of observation, phenomena like ultra-compact dwarf galaxies, dark galaxies, visible only through their gravitational effects, and fast-moving interstellar objects like Oumuamua continue to puzzle scientists. Each discovery challenges assumptions, suggesting that even our models of matter, motion, and energy may be incomplete. The cosmos is a gallery of extremes, light and darkness, creation and destruction, order and chaos. Every strange object, every violent event, every unexplained flash of energy reminds us that the universe is not tame. It is wild, majestic, and often incomprehensible. Humanity observes, measures, theorizes, and yet, at every step, we encounter the unknown. Even as we learn, the universe continues to surprise, proving again and again that reality is far stranger and more magnificent than imagination alone could conceive. The universe is not static. It is a stage for relentless change and dramatic events, some gentle and some catastrophic. Cosmic catastrophes are the engines that drive evolution on a galactic scale, shaping stars, planets, and entire systems. Consider galaxy collisions. Galaxies are not isolated. They are drawn together by gravity. When they collide, stars rarely smash directly into each other. Space is mostly empty, but their orbits are distorted. Gas clouds compress, and star formation accelerates. Supermassive black holes at the centers of colliding galaxies may merge, releasing gravitational waves detectable across billions of light years. These collisions can create elliptical galaxies, tidal streams, and spectacular bursts of light visible to observers far away. The Andromeda Galaxy, destined to collide with our Milky Way in about 4 billion years, will remake the night sky entirely. Supernova chains are another dramatic force. When a massive star dies, it explodes as a supernova, creating shock waves that compress nearby gas clouds, triggering new star formation. In dense regions, this can start a chain reaction, birthing entire clusters of stars. Supernovae also forge heavy elements like gold, uranium, and platinum, seeding the cosmos with the material necessary for planets and life. In essence, these explosions are both destroyers and creators. Gamma-ray bursts, GRBS, represent some of the universe's most extreme catastrophes. A single burst can release more energy in seconds than the sun will produce over billions of years. If one occurred within a few thousand light years, it could strip a planet's atmosphere or sterilize life. Though rare, gamma-ray bursts remind us of the fragility of planetary habitability in a violent cosmos. On smaller scales, stellar flares and coronal mass ejections can have profound effects. Our sun emits solar storms, occasionally affecting satellites and power grids. On other planets, extreme flares could strip atmospheres, rendering them uninhabitable. Even stars we consider stable are capable of unexpected fury. Cosmic catastrophes extend to the interstellar level. Rogue planets and stars can enter solar systems, destabilizing orbits and ejecting planets into deep space. Black holes, whether solitary or in binaries, can disrupt entire stellar neighborhoods. And the seemingly empty voids of space are not free from violence. Gravitational waves, dark matter interactions, and high-energy particles ripple unseen, subtly shaping the universe. Even time itself is a stage for cosmic drama. Tidal forces near black holes can spaghettify objects, stretching them into long filaments of matter. The merging of neutron stars produces kilonovae, briefly outshining entire galaxies and creating precious heavy elements that will one day become part of planets, oceans, and life. These catastrophes are not random chaos. They are the rhythms of a dynamic cosmos. Stars are born and die in cycles. Galaxies collide and reshape. Elements forged in violence seed life. The universe is both destructive and generative, a perpetual dance of creation and annihilation. For humanity, observing these events teaches both humility and awe. We see forces far beyond comprehension, yet we understand them, measure them, and even predict them. Catastrophes in space are reminders that we exist in a universe that is alive with energy, motion, and transformation, where every explosion, collision, and flare is part of a story billions of years in the making.